Hello everyone. Today's problem today is click array Nagasum. As we can see, we are given a array of n elements, and we need to split uh, that array into k partitions such that the maximum sum of these partitions is as minimum as possible. So let us check the given test case. This we are given four elements, and we need to make three partitions. It is given that we need to make exactly three partitions. So we have elements 1, 2, 3, and 4. So let us make out all possible combinations from this. Uh, if this we make this as one partition, then what we are going to get is as partition with someone. Then this can be second partition, which where we'll get some 2, and we just have only one partition left. It will be 3 and 4, which will have seven sum as 7. Out of all of this, uh, we have to pick the maximum sum, which will be 7. But out of all possible partitions, uh, these maximum should be as minimum as possible. So that is a question. The optimal partition given is we can make this 1 and 2 as one partition, 3 as 1 and 4 as 1, where we can get 1 plus 2 is equal to 3 as sum of one partition, 3 as second one, and 4 as third. Here we can see that we have uniformly distributed the sum over subarrays. So this partition will give us uh, minimum of all maxima possible. So the solution of this will be 4. If we can observe carefully, like uh, for some certain uh, amount of maximum sum, we will have more number of partitions, and after certain level, we'll get exactly k partitions, and after that sum, we'll get less number of partitions. Let us observe similarly for n case. Let us take k is equals to 2. Then let us take the same array. In this case, what happens is that if we try to make answer as 4, then let us check it. Uh, 1 is perfectly fine, and we can add 2 as well. 1 plus 2 will be less than 4. If we add 3 to this sum, the sum will be more than 4. So we cannot take this into the partition. So that's the reason this will become one partition, which will be of sum 3, and then this will be the second partitions, like subarray. Subarray will start off from here, and if we take sum, if we include 4 as well in the sum will be 7, which will be more than 4. That's the reason we take the 3 as second sum, and remaining is 4. But we are getting three partitions, but it should be actually two. So yeah, so that's the reason we cannot make 4 as possible answer. Similarly with 5, we can check this out too. Like this will be one partition. If we include 3, the sum will be more than 5. So we should stick to this one only. So this will have sum of 3. If the second subarray will start off from here. If we include 4, then the sum will be 7, which will be more than 5. That's the reason we'll stop here only. The next one will also be 4. So here also we can observe three partitions. If we try to make it as 6, what happens is that we can sum these three elements. Uh, so the sum will be 6, which is absolutely okay. And if we try to include 4, the sum will be 10, which will be greater than 6. So it is not possible. So this is a partition, and this is second one. So we are getting two sums from this. Sum of two partitions are 1 plus 2 plus 3 is 6, and the other one is 4. You get exactly two partitions, and we got k number of partitions, and the sum is minimum. So this will be the answer for this case. And for observation, let us report the next cases too. Like if we look at 7, for 7 as well, if we include 1 plus 2 plus 3, this will be 6, and we cannot include 4. That's the reason it will also work the same as well. Uh, so here also we'll get two partitions. And so let us suppose if we try to check if 10 is possible answer. Let us check it. 1 plus 2 plus 3 is 6, and we could include 4 as well. So here we can only do there is only one array, so there is only one partition of some 10. So here we have one partition only. From this we can observe that there is certain range where like the total number of partitions will be decreasing as we increase the sum. So initially it was 3, then it at some instant it was 2, and then after it becomes further less. So from this we can observe that we can perform binary search on the answers to get the least least minimum maximum sum. So this will be the answer, and let us see how we can perform binary search on it. So as we can observe the minimum element, like minimum sum will be the maximum element, but in this case it is 4. Let us observe. If we keep some less than 4, it is not practically possible, right? Like if we pick it as 3, then this we will already have some 4, which is not possible. So in binary search, the low will be uh, maximum element of array, max element, and the value of high. The value of high, we can go up to the entire sum. Like if we have only one sum, like one partition, we can go up to entire sum, right? So it will be uh, sum of array. And between this, if we can check out, like we can perform binary search on answer, and we can check out how many partitions it can make. Like if the number of partitions, if let us say we have three cases possible, if number of partitions uh, we can make is like less than equals to k, as in this case is uh, it is less than equals to, that means that the answer will be on the left side. So that's where we need to bring high to the mid. And if the second case will be number of partitions is equals to k. uh, if in this case, like we have two answers possible here, but as we need to extract the minimum of maximum possible, we have to extract minimum. That itself says that we also, in this case we need to bring high to the mid. uh, in the other case, if number of partitions are greater than k, let me erase this, I'm sorry. If number of partitions are greater than k, uh, which happens if the answer is towards the right side of it. Like if for two partitions, the possible answers are 6 and 7, which will be on the right of 4 and 5. So in this case, we need to bring low to the mid. So this will get us the answer, and we can find out number of partitions easily. So let us solve this. Let us take low. Low will be, as I said, it will be maximum element. We can find out using this function. And coming to the maximum possible answer, it will be a sum of entire array. So we can find out as well. So yeah, on this we need to perform binary search. Like while uh, we'll write a possible function in future, it is a Boolean type. And as we have seen in this case, these are the conditions we make sure the problem satisfies. In this case, as we need to bring height to the mid. So if it is satisfies the condition that the number of partitions are less than equal to k, that's when we bring on high to the mid. Otherwise, we'll will bring low to the mid because the answer lies on the right side. Now we have two possible answers, right? Like uh, we can have low as a answer or a high as a answer. As we need to get the minimum answer possible, first let us check out if low is the answer. We can find it out using this function. Like we'll check if low is the answer. If it is the case, we can return low, or the answer will obviously be high. So yeah, from here we can write out the um, possible function. So initially, the number of partitions will be one because uh, if straight away they give a as one, and we need to iterate entire array. We cannot iterate entire thing with one zero partitions, right? So the number of partitions will be one because we need just if there are three partitions, we need to just break it out in two places. Like here we break after two and we break after three, and there is no break after four. So they even though like we we already consider the first thing as a partition, so number of partitions will be one, and then we have current sum as zero. Now we just need to iterate entire array. Uh, if we observe the current sum exceeds the maximum sum possible, that means that we cannot include this element in the partition. So that's when we equate that to this element, and then uh, like it marks the beginning of new window. And since we have partition there, we increment number of partitions. Yeah. So if as we have seen, if partitions are less than equal to, okay, that's when we bring I to the mid. So we can simply return, I mean, this less than k. This should work perfectly. So it works perfectly. And let us come into that time complexity and all. Let us see the time complexity. Suppose if we take x as uh, total total sum minus maximum element, then we are performing bind search on x number of elements, which and we are iterating n elements, like n elements for checking out how many partitions we have done. So that's when the number of partitions. So the total time complexity will be n times log x. It will be time complexity. And coming to space complexity is nothing because we did not take anything new other than these variables like integers. So this will be the time and space complexity. Thank you.